In this series of videos, we're going to be looking at notes from section 1.4i, and our topic is the binomial theorem. And if you remember from the problems that we did in class, the binomial theorem has to do with taking a binomial, like a plus b, and raising it to a power. And so we're going to have a variety of problems that are connected to that type of problem. So the first thing I want to look at is the results from work that we did in class in our exploration on the board of expanding the quantity a plus b to the fourth. So that binomial to the fourth power. And if you remember, the solution that we got is 1 times a to the fourth b to the 0 plus 4 times a to the third b to the first plus 6a squared b squared plus 4ab to the third plus 1 a to the 0 b to the fourth. And of course that we could simplify that. You know, this would just simplify to b to the fourth, this would just simplify to a to the fourth, and so on. But we also talked about the fact that these coefficients that we have, the 1, the 4, the 6, the 4, and the 1, can be found with something called Pascal's triangle. And Pascal's triangle, remember, starts out with a 1 on the top, and then you just kind of bring the ones in each direction, and then you bring the ones in each direction again. But then in the middle, what you do is you add those. So we get a 2. And then we just continue. We bring down the 1, add to get 3, add to get 3, bring down the 1, bring down the 1 again, add to get 4, add to get 6, add to get 4, bring down the 1. And remember that these coefficients, or these numbers that are here, become the coefficients for the a plus b to the fourth power. And then going down, these are the coefficients for a plus b to the third, a plus b squared, and you can confirm this against what we did in class, and then just kind of what makes sense for these problems. A plus b to the 0, which is just 1. Here the coefficients are just going to be 1. Here, what you know about squaring, you get a squared plus 2ab plus b squared. And then recall that we also said that these values, 1, 4, 6, 4, and 1, come from 4 choose 0, 4 choose 1, 4 choose 2, 4 choose 3, and 4 choose 4. All right, and remember, you can also use the notation 4 choose 0 like that. So that means that this is going to turn into, if we write it out, 4 choose 0 times a to the fourth b to the 0 plus 4 choose 1 a to the third b to the first plus 4 choose 2 a squared b squared plus 4 choose 3 ab to the third plus, I'm going to erase a little bit here so that I have some room to finish this. Should be 4 choose 3 plus 4 choose 4 a to the 0 b to the fourth. So if we look at that now, we should be able to see patterns, and we talked about the patterns in class, but in particular I want to make note of the fact that we see a 0 here and then a 0 up here, a 1 here, a 1 here, a 2 here, so those match. I also want to point out that the numbers that are here, the exponents for a, are 4 minus 0, this is 3, so it's 4 minus 1, 2, so this is 4 minus 2, this is 4 minus 3, this is 4 minus 4. So notice that the number that's here matches the power, and then we're just and then these match. All right, we can see the 0 matching this, the 1 matching this, the 2 matching this, the 3's match, and the 4's match. So, and we have a summation here. And so we can write this in summation notation, and it will look like this. So I'm going to write it, and then we'll verify it. So this is going to be the sum, and we're going to use r as our counter. R equals 0 to 4 of, and then we always have a 4 on the top. So I'm just going to have 4 choose, and then notice that the denominators cycle through 0, 1, 2, 3, 4. So that's why I'm starting at 0 and moving to 4. And so we'll just put r down here. And then we're going to have a to the 4 minus r. All right, remember that, and then b to the r. So let me point this out. So notice that these three things match, right? And we can see that in all of these, the 0, 0, and the 0 here, the 1, the 1, the 1, the 2, the 2, the 2, and so forth. So that's our summation notation that we can write for expanding the binomial a plus b to the fourth power. So now what we can do is just generalize this, and you should notice that the power for the binomial, the 4, showed up here and here. And so if we generalize this to doing a plus b to the n, then we'll just replace the place where we had the 4 in each of these with an n. So a plus b to the n is going to be the sum for r equals 0 to n of n choose r times a to the n minus r times b to the r. And then we can also write that in, I think I originally had written it in an expanded notation, but we'll just write it like this. We also can write this as sum r equals 0 to n of, you could write n choose r if you prefer that notation, and then a to the n minus r, b to the r, right? And let's not worry about this row right here. So then, if you're just going to find a single term of the expansion, if we're just going to find one of these terms, not all of them, just remember that the single term is, or what we call the general term of that expansion is n choose r times a to the n minus r, b to the r, or, as we just saw, ncr, a to the n minus r, b to the r, right, where n is the binomial power. It's what power you're raising the binomial to. And r, what I want you to notice here, that if we're doing term 1, so let's go back up here just a minute. When we do term 1, which is this one, I want you to notice that r is 0. When we do term 2, which is this next one, you should notice that r is 1. So term 2, r is 1. When we do term 3, so term 3, notice that r is 2. So what I want you to notice is that the value of r is always 1 less than the term number. So if we know what term we're looking for, or if we know what term we're looking for, we can find the value of r just by subtracting 1 from it. So r is going to be the term number minus 1.